So just to summarize what's going on, dual quaternions. Now, what I was saying last class. Hey, how's it going? Now, what I was saying last class is that you're learning dual quaternions with Rashida, and she's going over the what. What are these things? That's with Rashida. Now, we've only got one more week left. So I was saying to Rashida, I'll talk about the why. Like, why would you use dual quaternion? So that's my job. All right. And something that you might realize now is that dual quaternions are part of something called geometric algebra. So that's what this thing's all about. This is geometric algebra. But inside here, if you squint long enough, you'll see quaternions and dual quaternions. You see points and planes. You see all sorts of beautiful things in there. Good question. Noel's asking, where is the dual quaternion? Well, the dual quaternion is... Actually, I can show it to you in the code. I'll open up the code. It's that top row. Something in the top row. Physics 2. We are in week 13. My goodness. All right, I'll open up the code. I'll show you where it is. Dual quaternion. Here it is. So if I minimize this a little bit, you might see it appearing. All right, so this is the dual quaternion in code. So Noel's like, where's that in the table? It's made up of 8 numbers. The first number is called real, and that's that green box in the top left, the number 1. Then it's made up of an actual quaternion, E23, E31, E12. You see right there, E12, E31, E23. Then it's made up of the E0s, E01, E02, E03, E01, 2, 3. That's over here. There's the E01, 2, 3. And right there, you see the E01, E02, E3. All 8 of them, yeah.
Just the last one.
Just the last one? Yeah, that's this one here. E01, 2, 3.
What is that to represent?
You're going to learn that with Rashida. I'll give you the quick, it gives you the screw motion. Like say you're screwing something in, you're rotating and translating. That's what that does. Yes? You're done teaching? Ah, okay. Just the... Yeah. The slurp. Yeah, I guess there's not much time. So yeah, she's not going to teach you. I'll teach you instead. Thanks for letting me know. Do you have an assignment with... Right, okay. All right.
What does that have to do with that?
Yeah, it's the pattern. That's
Pattern.
That's why you got to stare at this. That's why you got to stare at this pad and. Yeah, yeah, it is. It is.
Units are E0, 1, 2, 3.
Yeah, they're translating and rotating. All right, I'll just run the code from last class. What were we doing? Cool stuff. We wanted to make a cool camera. Yeah, we got a camera. This is a dual quaternion camera. Because what it does, it translates the whole world and rotates the whole world. So it's over there. So notice, in this code, the view is not a matrix, it's a dual quaternion, which is all very impressive and cool, but then somebody said, what's the point? I forget who it was. Might have been you. Yeah, might have been. But it's a good question. This is all fancy and stuff and great, but what's the point? Well, I wanted to talk to you about the superpower of dual quaternions.
I thought that was like a mathematical thing, a superpower. I got scared. There's like a power and there's like a superpower.
It is powerful. Where is it? Oh, here we go. Yeah. This is what we're going to do today. Oh, we're not going to get a cat. I wish we were. This is what we're going to do. We're going to do... We're going to do this. We're going to do a Slerp. So, yeah, let's see if we have time to get to this. Yeah, let's give it a go. You ready for this? All right. Now, I'm sure you all remember the Lerp. The Lerp stands for linear interpolation. And imagine this is camera A and camera B. And what the Lerp does is that it takes a number, t. T equals 0 at the start, and t equals 1 at the end. And you kind of go from start to end. As t gets bigger and bigger, you get closer to where you end up. Now with dual quaternions, we can do the same thing. We can start in that position, and now we're not just going to translate, we're going to translate and rotate. We'll end up with a different shot of the cat. And the cool thing is, it's going to work very similar to the regular Lerp. The Lerp, this is a linear interpolation, and the Slerp, that stands for spherical. And it'll be a similar idea. We'll start with t equals 0. When t equals 0, you're at the start. As t gets bigger and bigger, when it hits 1, you're at the end. Yes. Oh, yeah. Good question. Yeah, why is it Slerp and not Slerp? It actually stands for spherical linear interpolation. So that's a really good question. It's the orientation that follows a sphere, but you want the translation still to linearly get bigger and bigger. So yeah, it's actually spherical linear interpolation. Slerp it is. Yeah, right at the end. Maybe it does. All right. Okay, ready to do this? Let's do it. All right. So let's look at our code. Now what I want to do, kind of like in this picture, I'll need to bring up this picture often, is that I want to start and an end. So I'm going to have to make 2 cameras. I'm glad Scott's not here. He'd have a heart attack if he heard me talking about not one but two cameras. But he's not here, so let's quickly do it. So I'm going to make two, you know what, maybe I'll have two positions. I'll have position 1 for the start, and I'll position 2 for the end. There you go, how's that? I'll do the same thing with the orientations, 1 and 2. How's that look? Okay, so we're going to have one camera position orientation and then another camera orientation position. And that's going to be held in two dual quaternions. We're going to have view DQ1, view DQ2. And we're going to use one of them as the start and the other as the end. So, you know what, I'm going to make a few more as well. So I've got to finish this quickly before he arrives. Yeah, he wants to see what I'm doing. All right, how are you so far? We're just trying to set up this picture. I need a position orientation at the start and a position orientation at the end. All right, good. Next. Oh, I need a T. Yeah, let's make a float T. And T is going to go from 0 to 1. So maybe I'll start it at 1.1, say. T goes from 0 to 1 during the slurp. So I don't want to slurp right away. I'm going to press a button to make it slurp. So I'm going to set T, originally is greater than 1. And I'll figure out later when to set it to the right value. All right. All right, so we're going to make two views. So let's see. So I got camera position 1, camera orientation 1. Okay. 1 and 1. So this would be one of my dual quaternions. You know what, I'll bring the screen down so you can see this code. So this is just what we did last week. We built a translation and rotation, and you just multiply it in the right order. Translate first, rotate after. That's your view. Give it a run. We should still see the jellyfish. There it is. So that's my first view, and I want another one. I want another view where you kind of look at the jellyfish this way on. I want to see the side of the jellyfish. That'll be my second view. So let's try it. All right, so something like this. Camera, pause 2. Okay. Now what I'm thinking is that this will be where the jellyfish is, but off to the left. So the jellyfish's position plus something to the left, maybe like 20 units to the left. All right. So for the other view, I want to be looking I'll be on the left side of the jellyfish, but I need to rotate 90 degrees to look at it. So I want to do a rotation of 90 degrees to look at that jellyfish. Camera orientation number 2. So imagine the jellyfish is right next to us. I'm looking this way. If I want to rotate and look at it this way round, if you do the right hand rule, I need to rotate about Y. So this axis looks good, 0, 1, 0. But if you curl your fingers, positive angle goes to the left. So if I want to look to the right, I've got to put a minus 90. I think that makes sense. So minus 90 degrees about the y-axis. Then I'll do this stuff again. Oh, I'll have to get rid of these dual quat names. There we go. Okay, so this is the second view. So I made another view of the jellyfish, or the whole world. Really, it just has a different position and orientation. So if I set the camera to that view, we should be looking at the jellyfish side on. Okay, camera's looking over there. All right, so let's see what this looks like. View number 2. There we go. That's a jellyfish side on. Now the beautiful thing about the Slerp is that it'll get us from one view to the other, but not snap like that. Because you see right now, this is our first view. Jellyfish is to the left. And the second view looks totally different. We're right next to the jellyfish in the second view. Oh, yeah. Yeah, Zoe's got a good idea. Yeah, let's do that. Oh, it freaked out right away. I moved too quickly. All right, so Zoe wants this to be a key press. Let's do it. Okay. Yeah, it's kind of annoying having to hard code it like this. Let's do that. Let's say if you press the number 1, you get the first view. So view DQ is view DQ1. And if you press the number 2, you get the second view. Yeah, good idea. I like that. So I'll give it a run. Now if I press number 2, snap. Press number 1, snap. Boom, 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 boom. Oh, I'm going to get dizzy doing that. So instead of just snapping, we want to smoothly, spherically, and linearly interpolate between the two. It's the first time I've said all those words in one sentence. So that's what we're going to do. Okay. So let's have another key. Yes, 3. All right, let's have the number 3. Okay, focus. What are we doing here? So when we press the number 3, what do we want to happen?
The slur.
Okay. Let me type that in.
Set time to 0.
Yeah. Oops. Begin the slurp. All right. So let's set time to 0. Is that what I called it? I did. I'm not mucking about. Maybe I should call this slurp time. I might mix this up with something else. Slurp T. The slurp begins at 0. Right. And what are we slurping from? Let's say we slurp. Yeah, this looks pretty good. So we start from view 1 and we're going to view 2. Yeah, that sounds good. We are going to do a slurp. And now in our update, we're going to slurp. What should it be? Oh, it should be an if statement. If slurp T is less than or equal to 1, we want to add something to slurp. Slurp T, I don't know, plus equals 0.01. Okay, so what we're going to do in our update, we're going to keep adding to T, and hopefully the camera is going to slowly look at the jellyfish. So let's do it. So the view is going to be a slurp. Yeah, it's seen me coding this up before, actually. So I have coded up a slurp for you. If you are interested in the slurp, here it is. If you really want to understand it, you can look at the code. Let's see if I can look at the code. Go to definition. And look at that. I made a nice little PDF. If you really want to know what the slurp is doing, look at that. What's a slurp?
Which E is that?
What was an E? Oh, yeah, good point. What E is that? Here it is.
Euler's E. Okay.
Yeah, this is Euler's E. I think someone was asking last time. It's unfortunate. This is Euler's E. Euler's number. 2 point something. 2.7 blah blah blah. So I highly recommend check out what it does. Sorry, check out how it works. But I just wanted to show you it actually working. And then maybe you'll be interested to figure out why it does it. All right. So yeah, it's in the code. You can have a look at the little write-up I've got. All right. So let's do the slurp. So what the slurp's going to do, if you read that whole document, it just takes 3 things. It takes where you start and where you're ending. And this is the t value. The t goes from 0 to 1. So when t is 0, you're at the start. When t is 1, you're at the end. And this slurp just smoothly gets you from one to the other. So let's see if it works. All right. So I'm going to press the number 3. Whoa. That was pretty cool. Let me try again. I'll go back to the start. Oh, that was where we started. Look at it go. That's kind of cool. You can slow it down if you like, if you want to be very dramatic. Let's slurp it nice and slow. Whoa, look at this. This is so dramatic. Here it comes. There we go. Yeah, the whole thing should blow up at the end.
Just exploded.
Yeah. Well, there we go. It just deletes everything. What do you think? Slurp? Pretty good. They like it too. So, any questions on this? Do you want to know how it works, or are you done? Oh, yes. Wow. Yeah, that's a really good question. So the question is, in my slurp, I have a start and an end, but could I just keep going forever? And yeah, you can. Instead of instead of t going from 0 to 1, you just let t just keep going, and you can just go round and round. Yeah.
Could you also do that with like a matrix?
Yeah, that's why I wanted Scott here. Because the whole advantage of dual quaternions is to do this move. But, I mean, video games do this with matrices. Yeah, I can do it again. Here it goes. So every frame, it's changing the view. And it's doing it nice and smoothly. Yeah, that'd be nice. You're thinking how to do it. Yes.
You know those spirals that start like relatively large, and as they spin towards the center, it becomes smaller.
Oh, yeah.
Is that possible to do with the slime?
Yeah, so the question is, I mean, right now, we're doing this cat picture. Where's the cat? Yeah, we're doing this. So the question is, can we slurp and then keep going smaller and smaller and smaller? I guess you could have something called keyframes. Like you got start and end, and when you get to the end, make another start and end, and then make another start and end, and you can just keep having as many as you like. And that's the idea of keyframes, is that you have specific points on the trajectory that you want to hit. But yeah, you could do that. That looked nice.